Yeah, welcome here for our session supporting OCP accepted badging with SystemReady systems. And thank you again for coming over here. I think it's very difficult, right? Everybody has different slots assigned for their work today. But thank you again for coming. What we are going to do is we're going to be talking about this initiative of supporting OCP accepted badging with the SystemReady program. And I'm Don Wei, Standards Architect and Fellow from ARM. And we have Sung Park.
Hi, my name is Sung Park, Hardware Systems Engineer from Cloudflare.
Woo! Yeah, so the idea here is that I think traditionally for ARM devices, we have the partners developing software stack based on their silicon, right? Everything is customized with operating system and software on top. What we are trying to achieve with this SystemReady effort is to have the software just work on ARM-based devices. So you can imagine the same experiences that you would have from other architectures where you bring the common OS images, just to expect that image to work across the ARM devices, no matter where that SoC comes from. And we have quite a number of partners, from OSVs, silicon providers, hyperscalers, OEM ODMs, EDA vendors, firmware vendors, as well as communities working together. This is not just an ARM initiative. It's really a community work that we have. And we see a lot of the visions and the target market, especially for a set of the program profiles, are very much matching what the OCP market is heading. So we want to combine the effort together with this initiative. So in the SystemReady for servers, we currently have 2 threads. If you monitor the OSF efforts, right, the open system firmware efforts, currently there are basically 2 main open system firmware kind of efforts. One based on the traditional EDK2, one based on the Linux boot, right? So we support both today. So we have 2 profiles, basically what we call the bands, to support that. So with the SR band, basically we have UEFI, ACP, and SM BIOS interfaces in the firmware. And with Linux boot, we currently have Linux boot, ACPI, and SM BIOS. So as you can see, the Linux boot scenario doesn't have the UEFI ABIs on top. So that's why we currently have to have 2 bands to support this program. But eventually, through the effort of OSF, our hope is that we can merge these things together so we don't do additional fragmentations, right? The idea is that we can probably put the UEFI ABI on payload on top of Linux boot. So for us, we care about the interfaces. We don't care about which code base you use. This is the idea. And we want to support as many OSs as possible, just work. So right now, the 2 bands, the SR and LS in the SystemReady fits the server market. It has the minimum requirements on hardware, software to enable all the OSs to work. And then, for LS, certainly is currently only limited to Linux operating systems. But like I said, the idea is to combine them together eventually. And we have test suites to check whether your system is compliant or not. And so this level of interoperability may be assumed on other architecture. But like I mentioned, it cannot be taken for granted on ARM-based systems because our tradition, right, our legacy. So the SR and LS have been developed to provide the proven interoperability for this market. So what we're trying to do is we are working with the OCP specifications, the Open Compute specifications, to add additional requirements for ARM-based servers. We want to make sure that these servers are going through the SystemReady certification before we grant the OCP accepted badging. And as you may be familiar, there's a checklist of how a system can go through the the OCP accepted journey, right? So what we are asking or what we are planning to do is for ARM-based devices or servers, we want to have the ARM System Ready as the prerequisite. So System Ready provides the just works for OCP accepted ARM-based servers. So these are primarily designed for the hyperscalers and telcos. It's aligned with the OCP target market. So we see a lot of synergy between the programs, the System Ready and OCP accepted. So we want to work together, for and contribute, this to the OCP program. And I think you may have heard from the keynote by George on Monday that ARM has hosted the OCP Experience Center as the very first North America's Experience Center. It's in New Jersey. We're working together to provide the full support. This would be OCP accepted, ARM System Ready, and all the effort working together. As the OCP solution provider, ARM will enable the broader adoption of System Ready and OCP accepted together. So we're going to be collaborating with the community. And with that, I'm going to hand over to Sung to talk about the Cloudflare and the work that they have been doing.
Thank you. So my name is Sung. I'm a hardware systems engineer at Cloudflare. And Cloudflare, we are an internet security company and also a content distribution network service provider. And so our current network footprint, we currently span 275 cities in over 100 countries. And as a hardware systems engineering, we work with internal stakeholders. We scope out new hardware, and then we identify manufacturers, such as original design manufacturers that you guys are all familiar with. And ultimately, we bring in the hardware, and we validate the hardware. And so where I'm alluding to is, so we actually did deploy our first generation, what we call our ARM Edge servers. And then this is actually based on the Ampere Ultra Max. And this is also, in fact, System Ready certified under the SR band. And so we also have to, so we're making a comparison here against some of our previous generations. There is the Gen 10, what we call the Gen 10, Gen 11. The Gen 10 is based on the Rome 48 core, and the Gen 11 is based on the Milan 64 cores. So how does the ARM server stack up against our traditional x86 servers? The results are actually pretty impressive. So the Mystique, or the Ultramax M12830, it actually outperforms our 48 core by 17%. But while it's not quite as much as Milan, but as soon as we start looking into power consumptions, and this is actually one of the reasons why we actually started working towards ARM in the first place. The power savings that you get with ARM is quite significant. It is a fraction of our 48 core, or just about all of our x86. And when we put everything together, we get requests per watt, or performance per watt. And this is where it's astonishing. It's, the ARM servers is definitely, it delivers a very power efficient value. Typically what usually happens in the past is that performance is usually left forgotten, and then your power consumption is really low, and your request per watt is usually through the roof. But then here it's not the case. Your performance is actually there, and your power consumption is also there. And so what can be better about ARM and Ampere in general in the future? And so some of the things that we're very advocating for is memory encryption. We would like to have memory encryption everywhere. And on top of that, we're also making an effort to deploy OpenBMC everywhere. OpenBMC will definitely take a collaborative effort between the server manufacturer, ourselves, and also the silicon vendor. And yeah, some of the things that we are personally guilty of is we should be engaging more closely whenever we start scoping out new hardware, or we start validating new hardware. It's the BMC has been we deploy everywhere. So if you don't have the BMC, then it's we're kind of we can't operate without the BMC. It's become a critical piece in the server environment. So we would like to advocate, not just us, but then if anybody is looking into deploying ARM servers or have a similar business model that we do, where you guys heavily rely on the BMC, please make sure BMC is on the top of your priority. And with that, I would like to hand it back to Dong to close things out.
Thanks very much, Sun. I think what Sun has said about these areas where we can be better, of course, yeah, this is what we want to do with the community to improve. And what he raised about the BMC issue, yeah, that's a very good topic. So we have been working with the partners on a few additional specifications, actually, to try to bring the community together. One is the base boot security requirements. So this is about how we use TPM, how we use secure boot and secure firmware update. And at the same time, we also have the server-based manageability requirements. This is talking about how the BMC gets to connect with the SOCs and I/O components and everything else, how this BMC system is supposed to work, right, on ARM-based servers. So we collaborate with a lot of the partners together in this committee called System Architecture Advisory Committee. It's under NDA, so if anyone are willing to participate, we have a very open process for that. And so we created this security interface extension already based on the BBSR spec for some of the security interfaces. And we would certainly encourage people to develop their solutions for the security interfaces. But we are looking into standing up the manageability interface extension as well, MIE. And we have been talking in this OCP summit during this week with a lot of partners as well. We heard a lot of good comments. We need some sort of a tool, right, a compliance tool to check for the compliances, to make it easy for people like Cloudflare to use our system to deploy. So we certainly want to potentially leverage open source test tools. If you have ideas of where we can leverage and so on, please talk to us. And we actually have, it's unfortunate, a lot of the sessions are kind of combined to this Thursday, right? So there are a lot of parallel sessions. My colleagues are actually presenting with Ampere and others over in different tracks. But yes, the hardware management is definitely our focus as well. We want to make sure efforts like OpenBMC, DCSM, MHS, all these efforts are going to work with the ARM-based servers as well. I guess with that, Sun and I are available for questions.